of the DevOps for data science. Well, no, it's the final chapter. And then next week we will talk to Alex about the whole book and any questions we have, and he's been working really hard on doing another pass through, so things are changing behind us still. And then that's it. So it's very exciting. We made it through, or we will have made it through in a half hour or so. So with that, Ahmed, take it away.
Awesome. Let me share my screen. Okay. Okay. You share my screen? Okay, let's see where it's.
There it is. See it now.
Yeah, I don't see. Okay. So let's go to. So hello everyone. This is the last chapter in the DevOps for data science, and it's a pretty short chapter. Just we'll talk about we'll continue our discussion about enterprise. What is admin, IT admin, DevOps engineers are handling? What is the handling behind the scene? And I think this is pretty important if you want to collaborate or communicate with such people. So to just make the communication easier, and also to have the skill to, if you a one-man show in your organization, you can do your exploration better and easier. So yeah, this is the learning objective of this chapter: simplifying complexity using infrastructure as code. How then we will move to how to scale and stabilize workload in enterprise level in organizations. And then we talk about facilitating enterprise workload management with Kubernetes. And this is very much conceptual chapter, so it's not doesn't like have more practice like other chapters, but it's useful information to know how in an enterprise setting or company you you deal with multiple servers at the same time. So yeah, let's move to the next one. Okay. So simplifying complexity using infrastructure as code. One particular line that I really liked where Alex said that servers should be cattle, not pets. So if you are in your organization or somebody you know that you see him like taking care individually of each server and adding configuration manually, just focus on an individual server and do everything like configuration, feature management, all the package itself in just one server. And this is not just making you very not like inefficient in your time management. It also like costs a lot of time and costs a lot of money. At the same time, you are not in the right mindset to manage multiple server at the same time. So if you have one server, that's okay. But if in an enterprise level, you will probably have more than one, like 100 or 200, or maybe like more. So if to handle this, you have to shift your mindset to deal with it as a group. So deal it with as a cattle, not a pets that you take care of him and do everything that you do to pets. No, you just guiding it or think of it as a group, and you just tell it what to do, what should be done on a specific group, and this is automated. It should be automated, done to every single server of them. So if you, let's say we have multiple servers, they're like 100 servers. So if you run a script or something to update a version, our version or RStudio version, it should do this automatically. So this is how I see it, and it's pretty profound. And he began the chapter with an interesting analogy where he said, if you go to your boss and your boss said to you, we want to serve 2,000 scientists, serve application or platform to 2,000 data scientists, what should we do? And we have just one server. So now you should think out of the box, that because this kind of scaling is not like normal, like vertical scaling, and we will talk more about vertical and horizontal scaling. But we'll go back to this analogy after we get into the details of horizontal and vertical scaling. So Alex recommended a way to design an infrastructure, or how you could architect your setup. And he recommended the two-dimensional dev desktop prod setup, and it looks like this. Let's see, it's just too small. Okay, it's lagging. So okay, it's probably because I'm opening a lot of stuff. Okay. Let's go back. Yeah, this is the diagram that he write it or draw it. And basically we have a two-dimensional. So the first dimension is the staging environment and the production environment. And in each environment, you basically, the staging environment is just an experimentation for IT or admin or DevOps engineers, that they do their changes to it. And after they fully stage in it and do everything that they want to do, like upgrading configuration, managing a lot of environment at the same time, doing the scripting and behind the scene, then they promote or push the changes into the production, and the production itself consists of three layers of environments. Each environment are really like proposed or directed toward data science workloads. So basically the data scientist, here we say the IT admins group make changes to the platform staging environment, and the scientists are never granted access to the staging one, so they don't really have access to this. So but all their work is in the production environment that already been built by the IT admin or DevOps engineer. So yeah, this is a documentation architecture of building environment set up by Alex. Now he said, yeah, the ideal approach is to migrate servers and apps from staging to production, is to use infrastructure as code tooling and CI/CD to ensure that code changes always make into production at proper time. And he didn't mention, but he will mention he mentioned in the chapter that what type of infrastructure as code, because we have a lot of types. But I would say that it would be helpful if he mentioned that there is a really cloud-based infrastructure as code, and there is open source or some kind of tooling that really agnostic of the platform. That will be really helpful. But I think I just say it, so it doesn't matter. So yeah, let's go into how scale. Before I go on, is anyone has any question here in the slide?
Nope.
You hear me?
Yes, we can
I
hear.
don't see. Yeah. Okay.
Yeah, good.
Yeah. So let's continue how to scale and stabilize, um, yeah, how to scale and stabilize workload in enterprise level organization. So now we're talking about the vertical scaling limitation and how horizontal scaling is coming to rescue. Because of when we're dealing with one server and we want to upgrade it, we basically organization do this like 100 years ago, I don't know, but they just upgrade the resources, the capacity of this particular server, and they just add CPUs, RAMs, or GPUs on top of just a same server. And that's have a limitation, because if we go back into the analogy that Alex said in the beginning, that we want to serve 2,000 data scientists at once, this will not suffice or be enough. We'll have a limitation for one individual server to handle this kind of workload. And here we come to the horizontal scaling, where instead of we scaling up and down, we scaling out and in. So out and in, then we add multiple servers to handle the workload and distribute the workload. Um, that's how we can make scalability a factor obvious, because we just to scale down the if you have like a complex workload or heavy workload, we just add some other servers to the already existed servers, and we keep adding up until we are satisfied with the performance and the scalability, the cost, any other considerations that that organization is having. And before attempting, here he suggests that before attempting to horizontal scaling, it's vertical scaling, where costs climb linearly with computation. So you have to know where to stop, like the stopping point when you will go into the horizontal scaling and when we just take to the vertical scaling. And this done by just trying out how a particular server will handle a very heavy workload and concurrent requests at the same time. And I think this could is different in organization wise, but you basically don't do this very often, because always we organization search for horizontal scaling, because to distribute, they have a lot of data, so to distribute the workload across the servers, they should have multiple servers, not just one. Yeah, what else? So high availability. So here he mentions how we can achieve high availability, where if something goes wrong with a server or a service goes down for in a particular provider, for example AWS. So servers are in AWS region are getting down, all of them are down. Then how we could like tackle this problem. And here we, of course, the AWS says that we have like something called auto scaling, and we have something like load. We have some backup. We have backup, and we have auto scaling. But here he said that we use load balancers in horizontal scaling to um, to distribute the workload. This is how we could achieve the high availability, because the load balancer are managing the workload itself. And I think this is exist inside AWS services built in. We don't see it, but I think they have, of course, um, behind the scene of the managed service. And they have also, I think, separate service that do this if you are building everything yourself. So here we said that usually, yeah, I'm explaining here with an analogy what is a load balancer. And we said that imagine a restaurant with one chef that is trying to serve meals to 100 customers at once. The chef can only cook one meal at a time, so the customers are getting frustrated and very angry, and everyone is angry from everyone. This is the story of my life. And yeah, and getting frustrated with the long wait times, and some of them are with leaving. This is because the chef overloaded with a lot of like orders at the same time. And now imagine the restaurant hires 3 more chefs, and with the same skills and equipment as a first chef, the restaurant invest in a system where each chef has a buzzer, like in the music show or something. So and when the chef has a buzzer that goes off when there are new orders waiting for them, and the buzzer ensures that each chef knows exactly when they need to start cooking a new meal. So it's just like a system where the buzzer identify when is busy, the chef is busy or not, you can handle another order. And that's how he spread or distribute workload. At the same time, in this analogy, the chef represents the servers or clusters, and the buzzer represents the load balancer. So he checks if we check if the chef have or the worker should see if the buzzer is lighting up or off or on and off, and basically and decide on it where to send the order to continue the process of serving food. Now, yeah, this is how load balancer work in essentially how it's work, but it has all details that he mentioned in the book. I will not go into more details here. But yeah, so this is one, the using load balancer in horizontal scaling. This is how we could achieve high availability. Also, we can maintaining a backup. That's what I said before, of a load balancer and a database or NAS. So yeah, this is how he distribute. We have a couple of customers and a load balancer and multiple nodes that represent the servers that we distribute the computation workload on it. And the complexity is getting more simplified in this way because the workload is distributed and there is no overwhelmed node or servers that really handling multiple or big workload. And then we go to the state of or the database. It could be the database service in AWS. It could be like on-premise databases like MySQL, SQL Server, or something like that. Or could be like SQLite, like small database applications that really have like just saving customers' data, basically. And yeah, that's about high availability, how it's achieved. And here he suggests that we add autoscaling to and by autoscaling we mean that like the answer to it is just you save money when the traffic is low. So for example, he said that if you are working with a service, it's in daytime, like in the morning, and because of all business operation are done in the morning, at least is so every business operation is done in the morning, so we need the service up and running very fast and operate at its full capacity in the morning. But in the night, is we will not need that much capacity, so we with according to the use yes, the use patterns of customers, auto scaling are just fit when fit the servers dependent on the customers that are using the service. And that's how I think AWS doing it in first place. So yeah, many auto-scaling frameworks these days assume that applications are mostly stateless, and that's one drawback of auto-scaling. Some of the framework that if we, for example, like doing a Shiny app, and we are managing we did auto-scaling stuff. If one of the servers that has the data inside the app and the app itself running on the service, and the service, this particular server is down, then we lose particularly any states or data about the customer, which is very critical and dangerous. That's why he advises before to have a backup always, and to see if I don't know if AWS are handling this issue or not, but I think that it do, but I don't know, remember how it's handling it. But yeah, that's about this slide, how to scale and stabilize. This is give us a stability to the infrastructure or the servers in the enterprise level. When you do this kind of load balancers, backup, this is how you could establish that. So anyone have any question here or want to ask anything here? Okay.
No questions. Just yeah, it's thank you.
Yeah, I just minimize the video, so I don't see you when I speak, because the screen is small, so that's why I don't see you.
Yep, no problem.
Okay, so let's go. Awesome. So let's go to the last one. Pretty much it is one small also. So yeah, facilitating enterprise workload with Kubernetes. So basically, Kubernetes solves all three of the key enterprise IT challenges with running servers, where you don't depend on just one server that to handle the workload. You don't depend you don't like depend on the service or VM or any type of technology. You here depend mainly on containers to handle. You manage multiple containers at once with just one script. And here we could leverage infrastructure as code like Terraform or Puppet to just write one script in YAML and say, okay, I want to give it the configuration of Kubernetes, how it could, what groups inside it, like it should create, and we just run the Terraform command or Puppet command, and it does it all automatically. And this is how we could automate server management like pretty easily, I would say. And also because Terraform is platform agnostic, or Puppet, so if because if they are platform agnostic, they don't really have like attachment to the cloud provider. So if some reason Amazon tomorrow is we as a the already built, the usability part, or the already built stages or scripts could be run on other cloud providers like Azure or Google Cloud. That's how it's powerful. And also it's because the documentation saying like the documentation part, we do documentation by just running the script. And we also have I think I see it in some organizations where they also test this kind of scripts or YAML scripts, and they build also their own test on top of the Terraform scripts to make sure that not any kind of mistake happen in the syntax wise or in on requirement of that we are fulfilling here. So yeah, this is how we could, like on enterprise level, make it easy for just one person, even to like for DevOps engineer, just one person to handle all this kind of really heavy complex tasks with just running a script. We just write one script and say, like, descriptive language, of course. You describe what you want and it just run automatically. So this is how powerful this is. So increasing processing power of your cluster is usually as simple as few of mouse click. Yes, this is he talks here about the service. If you run in a service, EKS or other service that provide Kubernetes as a service. So on the other side, this makes it risky for a cost perspective because you using a lot of processing power by just describing what you want. You tend to have this risky behavior to add more or less and because you can. And this is a risky and really affect your cost effectiveness in terms of how you could reduce cost. You have to be really careful here. Helm here is the standard tool for defining what is running in the cluster. I think Helm, he didn't like explain Helm, the tool of Helm itself, but I think it's related to Kubernetes and it's some kind of manager inside Kubernetes. I don't. If you have any information about Helm, please feel free to tell me because I don't have this.
I don't either. So I don't know.
So I think because if we don't have like data scientists don't have to deal with this in complex ways. So we don't particularly run Kubernetes clusters by ourselves every time. So we don't really exposed to it. So that's reasonable, I think. So yeah, instead of the 10-step required of a typical server-based deployment, there are just 3 steps for Kubernetes. Yes, this is how we just like make it very easy in terms of back in the day, we have 10 steps that should just for one server to update their infrastructure, to update their upgrades or features. Now with Kubernetes, we just make it like 3 steps and could be 2 steps, just 2 steps more. So what are the biggest strengths? This is a question that been asked in a comprehension questions in the lot of the chapter. What is the biggest strength of Kubernetes as a scaling tool and what some drawbacks? And I said that strengths are automatic load balancing. So it exists load balancer exists inside Kubernetes. So it handles the load balancing stuff and horizontal scaling and all the stuff that we talked about before. And the horizontal scaling itself, the ability to add servers by just writing descriptive language like YAML. And of course, as we said, infrastructure agnostic. I can't pronounce it. So yeah, it's just in platform agnostic. So it doesn't depend on the platform cloud provider. You could have a service in both in AWS, GCP, and Azure. One of the drawbacks is managing and maintaining the Kubernetes cluster can be complex and time-consuming because you're dealing here with the enterprise level server management. So it's like having a lot of servers that could be 100 or 200 or more. So it just when you write them, you have to be careful and be careful of your time because it's consume a lot of time when you write in details what to do in a specific use case. And the more you be specific, the more it's the usability part of it become less beneficial because you are being so specific that this use case could be changed by time. So, and yeah, he said here it's really requires a highly competent Kubernetes admin, and this is true. Like it's a it's a way that I see that DevOps as engineers as a magic. I see that's how I see it because they know how to deal with almost every now and then problems that I face. So when you talk to them, I think this chapter will help us talk to them when we want something to be done. Yeah. And Also, the networking part in Kubernetes is a bit complicated. So this is the drawbacks, strengths and drawbacks. And I think that's it. That's it. This is pretty much it. We just finished DevOps for data science, and
Woohoo.
oh, yes,
Awesome. Yeah, I agree that like this last section has a lot where it's like, well, most of the time, hopefully I won't have to do much of this stuff, but I definitely have had to talk to people about it. And it depends on the size of the company you're at. I've definitely had situations where maybe I'm not the person in charge of it, but the person in charge of it is either overloaded or themselves new at it. So knowing kind of exactly what I need can be very helpful to get
especially
them,
guiding
you
the
know.
way. If you have either if you don't know, you could help each other because you have some kind of starting point to go from.
Exactly.
Yeah,
Yeah. Yeah. And I mean, this book has been full of things where I'm like, oh, yeah, I did that a much harder way before because
yep.
I just had to kind of figure it out and I was Googling the wrong things. So giving us the terminology is definitely helpful. All right. So like I mentioned, I'm going to check in with him again to make sure, but Alex said that he'll be available next week. So I will probably put something in the channel to gather any questions that we might have. I encourage everyone to kind of look over the book and think about everything and how you're going to use it. And he's very open to if there's anything left that I don't know, that isn't quite meeting our needs. Like after our last talk, he restructured the book pretty extensively. So I don't think he wants to do that again, but he is
We have to be careful.
open to the idea. Yeah. Yeah, he said that was that oh yeah, that his wife kind of asked him how he felt about the meeting, and he said he was kind of nervous going into it of, oh, are they going to make me, are they going to basically tear it apart? And we didn't, but we led him to kind of, I think it was something he was already thinking about, and he's like, okay, yeah, I'm going to do that. So that'll be exciting to see. But it's like you can watch the GitHub repo and you can see that he's putting something closer to finishing touches on things. Like I think he still plans to do another pass through the whole book, but it's getting there. It's been cool to see it happen. So very exciting. All right. Anyone have any other thoughts? Okay. I will see everyone in Slack.
Okay. See you guys. Bye.